Hello techs and welcome to the old video channel. This is one of the first set of videos about first order RC filters. This video is about high pass filters. In the next set of videos we will be discussing low pass second order RLC resonators, examples of designing, analyzing RLC networks. This video uses analogies, illustrations in order to solidify the concepts. This is like a crash course, straight to the point. We will not go into much details in this video, but its objective is to help you to solidify the basics. So complex concepts will be a lot easier for you to understand. So let's jump to the point and let's examine high pass filters. So this is our circuit right here, and we have our component. So, but to better understand how this circuit works, first let's examine how the capacitor works right here in this circuit. Because the capacitor is one of the most important pieces in this circuit. Let's see. In order to understand how this works, let's use an illustration and let's pretend that the capacitor is a hose. And right now I'm going to introduce to you to my pretty hose. It's this one. And well, the way it works is that if we have a hose with an obstruction inside, let's say a little pebble or something inside, and we open the faucet a little bit, we will see almost nothing coming out of the hose. So when it comes to the circuit, you won't see anything, no gain, right? Then now let's try something else. Let's get our new hose, and this has a faucet, and now we're gonna open the faucet a little more to increase the pressures. May see something, but not really, because there's still not enough pressure to get that pebble out of the way. So no, the circuit doesn't have anything anyways. So let's jump to the next hose. Whoa, this one is a pretty one. And let's increase the pressure a little more. Open that faucet and boom, all of a sudden, ta-da! We have some water on the other side. So the same thing will be happening with this capacitor. To analyze it, let's use I brought today very expensive generator right here as the hose with the pressure. So let's try giving it a little bit of pressure, a little bit of frequency. We'll see what happens to the circuit. See the voltage. Now what happens that little frequency? Oh my gosh, what's going on? Nothing is going through the circuit, the capacitor. Nothing happening. Let's increase our frequency. We'll see what happens to this high pass filter. And right here. Oh my god. Still, what's going on? I don't see anything on the other side. Man, what should we do? Let's give it a little more frequency. All the way to the high. Now we see our circuit. We see something on the other side. Okay, now we have something. Now we're talking about. So as the hose, the analogy that we use, this circuit now is working, but what happened is that as you were increasing, when we had a little low frequency, nothing was happening, and as we were increasing our frequency, now we reached the point where you designed the circuit to work with. So, and then we saw something on the other, so we saw some gain, but we had to reach that point. That's why it's called a high pass filter, because it works only with the frequency, the high frequency that you designed it to work with. So recapping, when you were inputting low frequency, nothing was happening, but as you increase and reach the desired frequency, the high frequency, then the circuit start conducting capacitor actually turned into a wire, and per se, we're saying that it got rid of the little pebble right here, and then all of a sudden we start seeing something because there was not just per se, let's say per se, not obstacle, not little pebble in the capacitor, and then the circuit start working with our high frequency. So just as an analogy, right? So what my point is that we needed the frequency, the high frequency. So now let's use a graph to understand a little more, to make the point clear. So we have right here this nice graph, and we have our friend right here that's going to help us with the we have the gain versus the frequency, and also what happens when we increase our frequency and our. So let's give it a little bit of frequency to the circuit. Let's see if we get some gain. Dun, 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 dun. Hey, come on, what's going on? I don't see anything on the other side. Well, because the frequency is still too low. Look, it's 1 kilohertz. Did I tell you to stop? No. Then keep going. Give me more frequency. Okay. Hey, I still don't see anything. Did I tell you to stop giving me frequency? No, you're mean. How come my circuit is not working? You just don't want my circuit to work. You're a jerk. Did I tell you to stop? Keep going. Then you will see something. Come on, I didn't tell you to stop. Fine. Yeah, we get something, right? Now we got something, right? Yeah, because we reached this higher frequency. So now, as we notice in the graph, when we had small frequency, nothing was going through the circuit. Stop right here. And as we increase 500 something kilohertz, then we started to see something. So that's basically how high pass filters work. In real life applications, high pass filters reject low frequencies and work with high frequencies, or whatever frequency you design the circuit to work with. Thank you for watching our video channel, and don't forget to subscribe and like the video. Leave a comment whether it is good or bad. It will help us to improve. Thank you.